In this video, we're going to look at operations with radicals. Let's start with addition. Now, similar to combining like terms with variables, when you had something like 2x plus 5x, when you combine them, they made 7x. But you couldn't do 2x plus 3x squared because they did not match perfectly. They didn't have the same exponent, so you would leave it like that. Same thing for radicals. I have to look at the radical, the square root. And both of them, it's a square root of 3, so they match. So all I'm going to do is combine the coefficient out front, and I get 7, the square root of 3. Easy. Let's look at the next one. Okay, in this particular problem, when I look at the two radicals, they don't match. So this is my final answer. I cannot combine like terms because nothing matches. Okay, little trick here, similar to when I have x plus 2x, your teacher probably taught you to put a 1 in front of here. So I'm going to put a 1 in front of this square root of 5. Both radicals match, so I'm going to combine the coefficients. 1 plus 7 is 8. 8 the square root of 5. Now I've only done addition, but the rules apply for subtraction. So let me go ahead and clear. All right, and I'm going to switch this problem. Let's pretend that this was a subtraction problem. It's the square root of 5 minus 7, the square root of 5. I'm going to put my 1 in front of here. So in this case, I'm going to do 1 minus 7 because my radicals match, and I get negative 6, the square root of 5. The rules apply the same for addition and subtraction, and that's because they're just inverse operations. Okay, now this one, at first glance, you're going to say, wait a second, the radicals don't match, I can't do anything. But I know that 8 is not a prime number, and I'm guessing I can probably factor it and change it. So from the last video when we learned to simplify radicals, I'm going to break this down to 4 and 2. I'm going to circle the 2 because it's prime, break down the 4 to 2 and 2. So I have a pair of 2's. So 2 comes out to join the 7, and 1, 2 stays at home. 7 times 2 is 14. This 2 that stays home goes right here. And then I'm going to add that to 5, the square root of 2. The radicals now match, and 14 plus 5 is 19, the square root of 2. All right. Let's move on to multiplication. The rule for multiplication is, I like to call them the plane numbers, my coefficients. My plane numbers can multiply with plane numbers, and radicals can multiply with radicals. So I am going to do 5 times 3, and I'm going to do the square root of 2 times the square root of 8. 5 times 3 is 15. One way to do square root of 2 times the square root of 8 is just simply the square root of 16. And then you can simplify and break it down. Now, hopefully you know that the square root of 16 is 4. So this just becomes 4. And 15 times 4 is 60. Okay? Now, another way I like to do it, and this comes into effect when I have bigger numbers. These are small numbers. I like to just go ahead. Let me erase this out of the way. I like to break my numbers down. So 2 is just a 2. And 8, when I break that down, that's 4, 2. Circle the 2, 2, and 2. When you multiply, you are allowed to combine factors. So I have one pair of 2's and another pair of 2. 2 times 2 is 4. I get the same exact answer. Okay, so let me fix this one so we can see it a little bit better. All right, so I'm going to do 3 times a negative 4. Leaves me with negative 12. And in this case, these numbers are bigger, so I'm going to go ahead and factor them out because I really don't want to do 15 times 45 and then factor it out. Those numbers are just going to be too big. So 15 is 3 and 5. And 45 is going to be 9 times 5. And the 9 breaks down to 3 times 3. Okay. So when I share all of these together, remember I'm not going to use the 9 because it's not prime. I have one pair of 3's. That's going to join the negative 12 out here. Sorry, I almost missed that. And I have a pair of 5s that are going to join, and this lonely 3 here has to stay home. So 12 times 5 is 60, times 3 is 180. So negative 180, the square root of 3. Okay? So let's take a moment and let's look at one and have you do that. Let's do 7, the square root of 12, times 3, the square root of 15. Okay, I'm going to count a couple seconds, but remember you can always pause the video, do the problem, and then start again. Okay, I'm going to take the 7 times the 3, that's 21. I'm going to factor my 12 into 3 and 4, which breaks down to 2 and 2. Let me circle all my primes, get rid of the one that's not. And 15 is 5 and 3. So if you notice, I have a pair of 3s, so 3 joins the 21. I have a pair of 2s that joins, and 5 stays home. 21 times 3 is 63, times 2 is 126, the square root of 5. All right, let's look at one more example of multiplication. And this goes back to when you learned FOIL. Good old friend FOIL. Let me move this out of our way. So we have to distribute the 4 to each piece in the other parenthesis. So 4 times 2 is 8. 4 times 5, the square root of 2. The square root of 6. Sorry about that. Is 20, the square root of 6. Then I come back and I have to distribute this to each term. So 7, the square root of 2 times 2 is 14, the square root of 2. Because remember, this isn't a radical. So 7 times 2 gives me the 14. And then I'm going to do 7, the square root of 2 times 5, the square root of 6. Okay, so this is going to be 35. And then if I break this down, this is 2, and 3. I have a pair of 2s, so my 35 is now going to be 70, because 35 times 2 is 70, and the square root of 3 stays there. If you notice, none of these match, so my answer would be 8 plus 20, the square root of 6, plus 14, the square root of 2, plus 70, the square root of 3. Because I can't combine any terms because none of the radicals match. Okay, last one, and this is a special case, which we will need later down the road, so don't stress too much if you don't see this one right away. Same thing, we're going to use FOIL. I'm going to do 4 times 4, which equals 16. I'm going to do 4 times negative 7, the square root of 2, which is negative 28, the square root of 2. I'm going to come back and do 7, the square root of 2, times 4, which is 28, the square root of 2. And then I'm going to do 7, the square root of 2, times negative 7, the square root of 2. And this is a special trick that I didn't talk about. When they match perfectly, you drop the radical, because I have a pair of 2s, so the 2 is going to come outside. 7 times negative 7 is negative 49, times the 2 is negative 98. Now in this case, I can combine these two because they're both the square root of 2. Negative 28 plus 28 is 0, so they go bye-bye. That leaves me with 16 minus 98, which gives me a negative 82 as my final answer. And down the road, you'll see why we want to do some multiplication to get rid of radicals and just have solid numbers. So we've addressed adding, subtracting, and multiplying, and we will address division in the next video.